Find the effective length factor K for column CE. In this problem, an unbraced two-story structure is connected with pin connections. The lengths of the columns and girders are provided, and the specific I-beams are specified for 4 of the members. We also know the slenderness parameter, lambda c, is greater than 1.50. The effective length factor for a column as part of a structural frame is a function of the end condition coefficients at the two ends of the column. So, for column CE, we'll focus on joints C and E. Once we know the two end condition coefficients, we'll use an alignment chart to find the effective length factor for the column, K. The end condition coefficient, G, equals the sum of EI over L for the adjoining column members divided by the sum of EI over L for the adjoining girders. For joint C, the column members will be AC and CE, and the girder members will be BC and CD. From the problem statement, we know the specific I-beams corresponding to these adjoining members, and we can look up their corresponding area moment of inertia values in the strong direction. Next, we'll write out the equation for G specific to joint C. Unless otherwise noted, we'll assume the modulus of elasticity is constant for all members. Therefore, it cancels out of the equation, and we'll revise our equation for the end condition coefficient at joint C. Next, we'll plug in the area moment of inertia terms, as well as the length terms, and our value of G at joint C equals 0.95. For joint E, since pin connections do not resist moments, pinned ends are assigned a value of 10 for their end condition coefficient. Returning to the alignment chart, we'll look up the values for GC and GE. Drawing a straight line between these points helps us identify the effective length factor for column CE, which equals 1.85. When looking back at the possible solutions, the answer is D.